Good evening and welcome to the session number 7 from the chapter of electromagnetic waves. And the topic for the today's session is the properties of the electromagnetic waves. So this session is in continuation of the session number 1, in which we have discussed some of the properties of the electromagnetic waves. And today we will be discussing a couple of properties of the electromagnetic waves, and in the next session, that is in the session number 8, we will be completing this topic. So in the previous session we have studied that electromagnetic wave is a transverse wave, and the direction or propagation of the electromagnetic wave is always perpendicular to the direction of the oscillation of the electric and the magnetic field, and at the same time the electric and the magnetic field are also oscillating perpendicular to each other. And in the session number 1 we have also seen that the speed of propagation of the electromagnetic wave is given by the formula, that is V is equal to 1 upon under root this is equal to mu into epsilon, where mu is called the permeability of a medium and epsilon is the permeability of that medium. And the electromagnetic waves exhibit the properties of polarization, diffraction, reflection, refraction, and interference. They obey the wave equation. The wave equation is given by, that is V is equal to F into lambda, where F is the frequency and lambda is the wavelength of it. So these were some of the important properties which we have discussed in the session number 1. Now today I will be taking two more properties of the electromagnetic waves. The first one here is that is the energy per unit volume of the electromagnetic wave in any medium is given by this equation, that is the energy per unit volume in a medium is equal to 1 by 2 epsilon E square plus 1 by 2 mu B square. Here epsilon is the permittivity of a medium and mu is the permeability of a medium, and epsilon is basically equal to epsilon naught into epsilon r, and this mu, that is the permeability of any medium, this is equal to mu naught into mu naught is the permeability of the free space, and mu r is the relative permeability. Here epsilon naught is the permittivity of free space and epsilon r is the relative permittivity, and here epsilon is the permittivity of a medium and mu is the permeability of a medium. So now this energy is equally divided between the electric and the magnetic field of this electromagnetic wave. So it means that this 1 by 2 epsilon E square will be equal to 1 by 2 this mu into B square. So if I just equate both these two parameters, then I will be getting E upon V is equal to 1 upon under root of mu into epsilon. Mu is the this is the permeability of a medium and epsilon is the permittivity of a medium, and this is equal to the speed of the electromagnetic wave. So from this relation we can also see that E is equal to V into V. So if the medium is free space, then this E upon V will be equal to C, where C is the velocity of the electromagnetic wave in the free space or vacuum, which is equal to 3 into 10 to the power 8 meter per second. So this is an important relation. So this is also an important relation. This is also an important relation, and this is also an important relation. Now the energy crossing per unit area per unit time. This is per unit time, and perpendicular to the direction of propagation of wave is called the intensity of the electromagnetic wave, and this is given by I is equal to U into V. So in the case if the medium is a free space, then this formula will be equal to I into, that is U into C, where C is the velocity of the electromagnetic wave in vacuum or free space. So in the next session we will be discussing a few more properties of the this electromagnetic waves, and after that we will be doing few important or you can say some numerical problems from this topic of this properties of electromagnetic wave. So till then, have a nice day. Bye.